This video explains interval class and demonstrates two methods for finding it. In the previous section on pitch classes, we found that in music without tonal function, the spelling of a pitch no longer matters. Likewise, we don't need to distinguish between different spellings of intervals in posttonal music. An interval is the distance between two notes measured in number of half steps, and an interval class includes an interval and all its octave and enharmonic equivalents. Here's an example. I'm going to show how these three intervals, despite register and spelling differences, are actually all the same interval class. Using diatonic intervals, number 1 is a minor sixth, number 2 is an augmented 12th, and number 3 is a major third. One method for finding the interval class between the two notes is to count the shortest distance from one note to the next on the clock face. First, let's circle the notes on the clock face. Remember that pitch class 0 is C in our system, and then the other numbers represent moving up by half step from there. For a review on how to find pitch class numbers, please refer back to that section of the book before proceeding. Number 1 is between D and B flat. Number 2 is between D and A sharp, and number 3 is between B flat and D. Notice that all three examples involve pitch class 10 and pitch class 2, and thus can be treated as the same from this point. Now we're looking for the shortest path between these two pitch classes. We can see the distance is 4 ticks away on the clock, or 4 half steps, whether measuring clockwise from pitch class 10 to 2, or counterclockwise from 2 to 10. Let's consider a real-world example. Imagine it's 10 a.m. and you have a deadline at 2 p.m. How many hours do you have left to finish? The answer is 4 hours. Similarly, if it's 2 in the morning when a movie ends and you started watching it at 10 p.m., how many hours long was the movie? The answer, again, is 4 hours. The number of hours does not change whether you're measuring forward or backwards. Coming back to the three intervals, we can now see they all belong to the same interval class 4. The major third and minor sixth only differ by which note is on top, or octave displacement. The two intervals are inversions of each other. Refer back to the chapter on tonal intervals for review. A minor sixth is actually 8 half steps, but the shortest path on the clock was 4 half steps. Notice the farthest distance away from any point on the clock we can get is 6 half steps away, a tritone. This means that the minor sixth in this example and any other interval larger than a tritone will be categorized in the same interval class as its inversion. The augmented 12th, or augmented 5th if the two notes are placed in one octave, is also the same interval class. That's because spelling and octave are not taken into account when figuring out interval class. The B flat is now spelled A sharp, and the A sharp has been moved up an octave, but the two pitch classes are still the same distance away on the clock face. If you prefer not to use the clock face, there is another way to visualize interval class using more familiar tonal intervals as a reference. Here I'm going to recreate the chart that appears in the text. As just shown, the largest interval class is 6. A minor second is 1 half step, and thus interval class 1. Let's keep going up by half step to major second, minor third, major third, perfect fourth, and tritone. The tritone is the halfway point of the octave, and therefore anything larger than a tritone is simply an inversion of one of the smaller intervals. They will belong in the same interval class. Now we head the other direction, with perfect fifth, the inversion of perfect fourth, minor sixth with major third, major sixth with minor third, then minor seventh, and major seventh. The intervals belonging to the same interval class are in the same vertical column. When using tonal intervals as a reference, there is a danger of making errors due to enharmonic spelling. The chart does not include augmented and diminished intervals, so those have to be reconceptualized as their more common equivalents. For example, what if you were asked the interval class between these two notes, D flat and F sharp? You may be tempted to look at the thirds on the chart first. This interval is actually an augmented third. An augmented third is one larger than a major third, so it belongs in interval class 5. It's an enharmonic equivalent to the perfect fourth. A good trick is to respell one of the notes to make the interval more straightforward. For example, you could respell the first note as C sharp to make a perfect fourth with F sharp. Or you could respell the second note as G flat to make a perfect fourth above the D flat. In this video, we showed two ways to conceptualize interval class. The first method was to find the shortest path on the clock face and count the distance. The second was to think in terms of diatonic intervals and their inversions, as laid out on the chart.